Hello, Incus 6.4 has just been released, and this is going to be the video overview for everything that's new in this release. I'm Stefan Greber, I'm one of the maintainers of Incus, and let's look at what's new in this release. So, as I wrote in the announcement, it's a pretty well-balanced release with new stuff for basically everyone. It includes some improvements, both bug fixes and new features on following the addition of OCI application container support in the previous release. It also adds some new features that are relevant to either normal system container users or virtual machine users, and then a number of features that are meant more for larger scale deployments. So things like clusters, projects, and the like. It also includes a lot of bug fixes. Bunch of them came through production environments and figuring out a bunch of issues recently. So there's a bunch of fixes, especially around storage, clustering, remote authentication, all of that, like fixing a lot of mostly small annoyances, but that, kind of compound. We also get a bunch of other bug fixes kind of all over the place, thanks to LXD having gotten an update into their 5.0 stable branch, which is still under the Apache 2 license. So those are changes that our system monitors and then starts to import into Incus. So we've got a number of changes that have come this way. There's more that's going to be reviewed and included into 6.5. But that's meant that 6.4 is a pretty bug fix heavy release that should really fix a lot of small annoyances and issues for everyone. All right, let's look at the new features. Okay, so the first couple of features are actually related. So the first one is the addition of configuration options on top of cluster groups. Up until now, the only thing you could do with a cluster group was adding servers to it and then using the group for placement. Now you've got the ability to actually set configuration keys. So the usual user.type keys that you can use for extra metadata effectively, as well as, and that's the second feature here, two new configuration keys per CPU architecture that are used to set what the CPU baseline is within that cluster group. So that lets you create a cluster group for a number of servers. You can then identify what CPU base model you want to expose to virtual machines, and then can even tweak the specific CPU flags. It also supports automatically generating that for you. So you can set the baseline as being KVM64 and then the flags to auto, and it will automatically scan all the servers currently in the group and then compile a list of flags that they all share together. That makes it pretty easy to have a group of servers that are not exactly the same CPUs, and then run that logic to make sure that that what's exposed to the VMs is nice and consistent, which then means you can safely live migrate within that cluster group. So that's really that was the reason for adding cluster group config, but cluster group config also useful in general. The next feature is particularly relevant to OCI users, but potentially also to others, which is the ability to create a custom storage volume and then create some subdirectories on there, and finally attach those subdirectories directly at specific paths within containers. Concretely, that means we can now go and create a storage volume for all of your application containers configurations and storage paths and the like. You can attach that to a normal system container, create all of the directory structure that you want for all of your data, and then pass in those subdirectories to specific application containers you're running, and they're effectively going to have their persistent storage handled that way. This is not a huge deal for people using Incus standalone, just on their laptop, because they can just use normal local directories and pass in those paths. But when you're dealing with a cluster, this becomes particularly useful, because now, like within a cluster, you don't really like using anything that's really local to a machine. Instead, you want everything to refer to objects that are available cluster-wide, so in this case, custom storage volumes. Next, we've got some improvements to projects, specifically project limits. So up until now, you could set a limit on disk usage. So you could set limits.disk and then 50 gigs or something like that. And the project would now be limited to allocating up to 50 gigs to its instances, images, and storage volumes. But the reality is that in many environments, you have more than one storage pool, and your different storage pools might be because some of them are remote, like fully replicated Ceph or LVM cluster, and some others are not and are just local storage pools, so ZFS, BurFS, and the like. But also could be different storage classes. So you could have NVMe, SSD, hard disk drives, and then based on that, you might not, given a project where you want to give, 2 terabytes of storage for a project, you might not want those 2 terabytes to be usable just on NVMe. You might be fine with that project using like 1.5 terabyte of hard disk, and then 400 gigs of normal SSD, and then 100 gigs of NVMe. So that's kind of what we were missing. There was no finer grained limits around storage, but now there is. So now we can set limits.disk.pool.pool name, and then that limit applies just to that specific pool. Limits.disk still remains as the overall limit. Another thing that this lets us do is set a limit to 0, at which point it completely prevents the use of that particular storage pool and even makes it go away from storage pool listing. We're going to go through the demo afterwards, but you can see in the announcement here, I'm just kind of showing that where I've got 2 storage pools. I apply the limit. I set 0 to default. That causes, I set 0 to foo, which then causes it to disappear entirely. So we only see default at that point. Then we can allocate the maximum size allowed on default. Creating again fails because it's reached the maximum. Then set a 5 gigs limit on the outer storage pool, so that effectively makes it reappear, and then can create the instance there, which then gets us to the maximum of 10 gigs that was set. You can see here the result with 10 gig out of 10 gig, and then each pool filled with 5 gigs. So that's very convenient for shared environments with more complex kind of storage solutions, because you can now really go and apply specific limits on specific pools. Next thing is a small improvement to Oven. So Oven virtual networks, so far have always had to be tied to an uplink network. And that's effectively like an IP address gets allocated on the uplink that becomes the router address for the virtual network. All traffic in and out, like in and out of the physical network, then goes through that IP address that's been allocated. And that's how you get connectivity in and out of other networks. But you don't always want that. There are definitely environments where you just want a network that all of your VMs can be on and interact with each other, but doesn't actually provide any outside connectivity. There's a way to deal with that, or with what we had before, which involves things like either creating a normal Oven network and then putting ACLs in place to prevent all external ingress and egress, or creating a fake uplink network that's like a unused VLAN or something like that, and then using that, which similarly would connect you to nothing and effectively provide an isolated environment. But now we've added support for just passing none as the uplink network name. And if you do that, then you do get a normal Oven network, you do get IP allocation and everything on it, but there is no outside connectivity whatsoever. So just a small addition, but can be very useful. It also effectively saves IP addresses on the uplink network, because you don't need to waste an address just to firewall off all traffic. You can just tell it not to use an uplink at all. And then you get the isolated network that way. Next, we've got a improvement, well, like a new option for containers, which is the ability to run LXCFS on a per container basis. So LXCFS is that virtual file system that we have, which provides things like the container CPU files, memory files, etc., effectively showing you what limits are applied to the container. Without it, the limits would still apply, but you wouldn't be able to easily see them through normal command line tools. That works pretty well. That's been working very well for a long time. The main issue we have with LXCFS is that as it's running as a single daemon that's shared by all containers, if that daemon crashes for any reason, it effectively takes down all the containers, because now all of those files become invalid, and the only real way to fix it is to get LXCFS running again and then restart all the containers, which is not really ideal on very busy systems especially. The other issue is that if one container really starts hammering a specific file, that can use a lot of CPU on the host side and eventually cause other reads from from other containers to start slowing down as they all try to go through the same extremely busy LXCFS. That's never ideal. So the option that we've added now is to get a per container LXCFS instance. That comes with elevated resource usage in general, because now you've got that extra process running for every single container. But it does mean that if it crashes, the only thing it affects is the one container that it crashed for. And if a container is abusing it for some reason by like doing a tight loop, reading some files or something like that, then it will still burn CPU for sure, but it's not gonna impact any other container trying to access those files. So that's a pretty useful option to have. It definitely is a bit of a trade-off, so you have to figure out, what's best for your environment. But you can set that configuration key, and then next time a container starts, it just ends up getting its own LXCFS instance. And lastly, we've got a small but probably quite welcome improvement to the launch command, which can now take an environment file. When that happens, all of the key values that are set inside that environment file are then converted into matching environment config keys on the Incus side. So here in the example, we can see that MySQL container with a few variables, so database, user, password, and random root. And we can see that they're actually landing as config keys here in Incus. The other environment keys you're seeing are just the default that comes with that OCI image. They were not specified by the user, but are just there by default. And that's it for this release. All of the cool new features. So now let's go and try to show those to you. So let me just go get that out of the way. And we're going to start with a cluster. So let me go on a cluster. So that's my usual test cluster. Here we go. It actually has cluster groups already configured, so that's convenient. We go look at the list. So it's got 4 servers. Just change the font size. There we go. So it's got 4 servers and 2 groups. So the default group has them all. Foo only has 2 of the servers. I don't know if it's actually running anything right now. It's running 1 container. Okay. So let's start by looking at the config for Foo. Not for Foo, for default. We can see that default is currently currently configured. So let me just unset that for now. So we can look at the out of the box behavior. The baseline there. So if we just launch a new VM, let's do 24.04 Ubuntu as a VM, okay. So that will get us a VM with the default behavior, which as of Incus 6.3, that was a feature in there, will be the baseline CPU of everything in a cluster. They're all identical, they're all AMD EPYC. So you can see AMD EPYC, 24 cores, 2nd gen CPUs. So that's gonna get picked up and be replicated inside of the VM out of the box. And go look in there. There we go, authentic AMD. So that's effectively using the baseline, and we've got the same CPU flags. So what it did is it did use the generic CPU because the VM is configured to be migratable. So there's a config key v1. If I expand, because it's coming from a profile, I've got a profile that sets this key, migration stateful true. So the VM goes into a mode where it can be live migrated. And to do that, it doesn't expose the exact physical CPU. It exposes a generic version of it with the same CPU flags, which is what we're seeing. We could actually go and play with that a bit. If I go and override, I'm just stopping that VM. It's taking a bit longer than I expected. There we go. if we go and set migration stateful to false, at that point, the VM will no longer be live migratable, but it's now gonna show the exact CPU, including the model and vendor and everything, which is what you also get in a standalone Incus environment. So let's see if it's booted already. No, not yet. Come on. That's taking a while. There we go. Cool. So let's go look CPU info. There we go, AMD Epic. So this time the full thing is actually passed through. All right, so that's for the default behavior. Now I'm gonna stop that VM again. And we're gonna go and make it back to stateful. Okay. And that's where we can kind of start playing now. I do have that other group, but for now, what we're gonna do is actually play with the existing one. So again, if we look at the cluster group, the default group, there's nothing set right now. What I can do is do something like actually the value I had before, for example. So instances, VM, x86, 64, baseline, go to dual. Because the group set, what did I mess up? Instances, up CPU. There we go. And now if we start the VM back up, it's gonna pick up Core 2 Duo as its CPU architecture. And you could even go and play with specific CPU flags. I just don't remember what's available or not on Core 2, so I can't easily play with that. We can play with another example where I do know how to, like what CPU extensions can be easily masked. Okay, so let's see. It's running and there we go, Core 2 Duo. Okay, so once again, I'm gonna shut that one down. And then use the example I used in the announcements. We're going to do baseline as epic v2, and then flags will do minus svm. Okay, then start that back up. So that will get me effectively, yep. Is my svm stuff a bad example for that particular CPU? Is that what's going on? Yeah, probably. Actually, I did this one for the example. It would make more sense. Let me do that. Yeah. Okay. So if you use a specific CPU model, then playing with extra or removed CPU flags can be hit or miss because it's going to depend on whether QEMU thinks this is valid or not. So in this case, it did try to do epic v2 as VM. You can actually see it here. And that was not allowed by QEMU. But what I did after is say, actually show me the host CPU, but now remove the SVM flag from that, which is effectively the virtualization flag. So if we go back in there, now we should say epic 24 cores, but now SVM is disabled. Okay, so that's one way to kind of play with it, using just the default group. Now, the other thing you can do, and I mean, that's effectively the same concept, but you can have a second group. That's what we can see here, this group foo with 2 servers in it. And in this case, we can see a very long list of flags set on KVM64. So that's because what I did, and actually I can go and set it to show it to you, is foo instances VM CPU x86-64 flags. Okay, so if I do that, I just get a very baseline KVM64 CPU with pretty much nothing enabled on it. But what I can do is I can set flags to auto, and so long as the baseline is also KVM64, it will go and look at all of the servers within the group, so in this case servers 3 and 4, and look at what CPU flags they share, and then go and compile a profile that will make live migration possible. So it's very, very similar to what we've done by default since 6.3, except that now you've got more flexibility because you can have that profile be generated just on a subset of servers. You can go and edit it and tweak it and add CPU extensions and remove some and do what you want. And then once you have that, you can just move your instance to that group and then starts the instance. And from that point on, that instance will be using that new baseline CPU and set of CPU extensions. Again, gonna take a little while to boot up, but we should then see that it's running on a standard generic KVM CPU again, with that set of CPU extensions available to it. Okay. And here we go. Command KVM processor, and then the list of CPU extensions is set. So that's for that feature. Now, for the next one, I'm just gonna go back to my local system. Okay. I think I should be in my demo project. Yes. Okay, so this is the next feature is around using subpaths for attaching the specific container. And for that, I'm gonna be starting by creating a volume. So we're gonna create a new volume in a default pool, call it, just call it vol. Yeah. Then gonna launch an instance. So let's do it 2404 and call that, let's call it demo. Okay. And then just do the standard thing of attaching, so adding a disk device to that container. Can call it vol, it's a disk. The pool is default, the source volume is vol, and the path will do /vol. Okay. Now if I go in here, we've got /vol mounted, so working file system. That's perfectly normal. We've had that for a long time. But now what I can do is do vol, let's do ctn1, ctn2. Okay. So I've created 2 directories. And now I can do demo ctn1, demo ctn2, and can go and add that storage path. I will just do on demo ctn1. And the source is gonna be, we want the subdirectory, so ctn1, there we go. And then 2 on 2, okay. And now if I go in those containers, so ctn1 here, info, which is the word ctn1, so we know which is which, and then do the same thing here. Okay, and so they've each got their own mount. And if I go look at the first container, and we go look at vol, then ctn1, ctn2, that effectively just lets us create a custom volume, and instead of attaching it fully to every single instance, you get to attach just a subset of it. And again, this is particularly useful if you're thinking of setting up an OCI or Docker container image on top of Incus, because now you can use something like well, actually I can show you another feature just by doing that. But so say we want to do MySQL, we do MySQL.env. I'm gonna actually go and copy paste from the release announcement the variables that I used. So that was for a WordPress database in this example. I don't know what path it stores its database in, so I'm gonna just quickly look up that on the Docker Hub. Because it will typically let you, ask you to pass in a specific path for storage. Let's see. Where does it say it stores its data? Where to store data? Okay, yeah. Valid MySQL. Okay, cool. All right, so what we would then do is create a new container, call it, use the MySQL image, call it MySQL, and environment file is mysql.env. I'm using create here instead of launch, so the container doesn't start at all, it just gets created. So just preparing the image. And then what we'll do is actually go back into that demo container, create a new path for the MySQL data. We could create another path for MySQL config if we wanted the config files to go somewhere specific. Then attach that to MySQL and start it. And at that point, it's gonna store its data on that custom volume, which means we can go and rebuild the image, the MySQL container with no issue. and we get to still control it from that other container. So in here, vol mysql.data, and then config device add to the MySQL container, quote data, disk source is vol/MySQL data, pool is default, and the path is valid MySQL. Okay. And now I'll start the container. Okay, so that should start the MySQL container. And in here, we can go look at what it wrote, which is the MySQL database data and everything. Now, obviously, there's no data currently in that container, so it's not the most useful demo ever, but I could normally do a rebuild. In this case, it's running, so I need to force it, do docker MySQL, and that's gonna go and delete the MySQL container and reset it from the image. Start it back up, but because all of its storage is stored externally through that volume, it will just pick it up and you won't lose anything. So that's kind of the normal Docker behavior where your environments come from a file, your persistent data is stored on persistent storage. So that's how you would do it now with this new feature. And I got to cover 2 features in one. All right. So next one in the list is the storage pool project limits. All right. So I'm in a project, obviously, right now. I'm in a demo project. So if we can look at the demo project, you can see it's using 20 gigs, but there is effectively otherwise no limits in place. I think I'm probably gonna run into a small issue if I set a limit, but let's try and do that anyways. Set demo limits to disk. Let's do 100 gigs for those. Yeah, exactly. So that's because if you set a limit on a project, you need every single object to then have a size set so that it can be evaluated against that limit. Here, I definitely don't have that, so that's causing a small issue. I'm just gonna need to do a bit of override on those instances to actually give them a size. I think if I give them 2 gigs each, which should be all right. Actually, I should be able to do it on the default profile in one shot. Let's do that. Profile device set default root disk and one size. Okay, let's do that. Okay, so now they all have 2 gigs of root disk size. That's good. And I need the same thing on the volume. So that was also going to have a problem with those. So that's just the custom volume created earlier. Storage volume set, so default vol size, and I'll give it 10 gigs. There. Now that should be fine. So I should be able to apply a limit. Yep, limit of 100 gigs applied. Cool. So project info demo. There we go. 100 gigs limit, currently 18 gigs used, so there's 10 gigs that's reserved for that volume, plus 2 gigs per container, gives us 18 gigs. So that makes sense, it's fine. If we go and look at the storage list, I currently have 2 storage pools. We could say that, foo is very fancy and NVMe expensive. I don't want my demo project to have access to it. So a project limit could be set to prevent me from accessing it. So limit disk pool foo and 0. Project set on demo. There we go. Now if I do the listing, it's gone. I can't see it anymore. I can't do anything with it anymore because I'm not allowed to write any bytes to it, so there's no point in showing it to me. It's gone. But now let's say I was being generous and I do want to give it, but only limit it to 10 gigs. Then I could do that, at which point it's gonna reappear. And if we go look at the project info, it's there with 0 bytes on it. And so now naturally I can go and start, creating another container. This one's gonna go onto the default pool. But if I do force it onto foo, I'm trying to figure. Oh, right. When I do that, it forgets the size argument, so I need to actually again specify the size. I'm allowed 10 gigs, so just for kicks, let's do 12 gigs. That fails, it's too large. So that shows the limit actually working, because it would, we've got plenty of space in the general location, but we don't on the pool specific one. And now if I do 10 gigs instead, it's gonna consume all of the space and we're good. So this is really pretty useful feature for anyone who's got like different classes of storage. You can do that obviously for any, it's particularly useful if you're sharing projects with other people, but it can also be useful for yourself to just avoid kind of accidents and make sure, like make it more conscious if you need to actually increase your usage of one type of resource or another. All right. Next, we've got isolated oven networks. So for that one, I need to go back to my cluster. Server 01. That's a cluster that has oven set up. It actually probably has it sufficiently set up that I have stuff running on an isolated network. So I'm just gonna go and clean things up a bit. So I deleted that VM and the other container that was already running. And I think I've got the oven isolated network here that can go away. Okay. All right. So again, if we look at the list, we can see here one oven network. This one is a normal oven network. So if we go look at its config, it's got an uplink set. So it's got an actual uplink network, and it's got an IPv4 and IPv6 address it pulled from that network, and then provides provides connectivity to instances running on it. So if I go and launch like a 24/4 container and put it on that network, it's gonna start and actually have proper outside connectivity. Or maybe not. That's slightly annoying. Why wouldn't it? This is my development cluster environment, so who knows? Oh, I know why. Okay, yeah, that's gonna be a bit of a pain. So the reason why this doesn't actually work is because this is nested virtualization with VMs. And I'm pretty sure I need to go and tweak the underlying oven mode to make this work. Because it's actually oven in oven, which is, again, fine for development to make things easier, but not great for demos. Let me just figure out if I've got the oven commands handy to fix this. Oh yeah, okay, it's the set address stuff. Okay, those. So let's see. With a bit of luck, I'm dealing with the exact same UIDs and GIDs, and it just works. Nope, no such luck. Okay, well, that's gonna be a bit too annoying to fix then. All right. Basically, the issue is that the uplink network I'm using is itself an oven network. And within oven, the default is to not allow any unknown MAC addresses. And because this is coming from an unknown MAC address, it gets stopped. So I've got those commands I usually run on the underlying network to tell oven, actually, it's fine to see other MAC addresses, and then that fixes that connectivity issue. So anyway, you're gonna have to take my word for it that this default network does have proper connectivity, unlike the one I'm about to create, which really won't. So if I network create oven isolated and put as the uplink none, oops, I forgot to specify the type. So it thinks it's a full bridge or something. So target oven. Okay, what the hell? Network creator, okay. Oh, yeah, never mind. This is supposed to be type oven. There we go. Cool. So that network is now using none as the uplink and is therefore fully isolated. Again, you're not gonna really see a difference because the previous one was broken in a way that makes it look identical. Okay, just loading that in, and here we go. So now we've got two containers. They actually each have their own IPv4, IPv6 address. We can see it on different networks. And I mean, you can obviously show that C2 will not get any kind of outside connectivity. There we go. And one thing I can actually show is the oven configuration to just show the difference. So if we look at the config, they each have an internal switch. So that's fine. That's what the instances are connected to. So we can see the internal switch that's the default network, and for the isolated network. But then the default network has an external switch, which is used to connect to the external network. The one that's isolated does not have that. And then the default network has, its router has external facing port and has NAT configured. That's all we can see. That's what we can see all here. And we can see it's got an IP address on the external network here. Whereas the isolated one is here and it just has its subnet configured, but it doesn't have anything external. It doesn't have an external switch, an external router port, or NAT entries. So that's really the difference for the isolation, for the network isolation here. And last thing is the per instance LXCFS stuff. So actually I had a good comment for that, just this. Oops. That should show a bunch of things running. Yeah, so we actually see a bit of a mix of things running on the system because it's pretty busy desktop. I don't actually know what my current setting is, so let's look. Do I have it per instance or not? I do. Okay, so if I restart, and we're just gonna look at a specific container. So there's a container here called speed test. I'm gonna stop it. It's in the default project. Okay, gonna stop that container. And then, so if we look, there's nothing running. If we go and unset that config key, and we start speed test in the default project, there is no LXCFS running. If I go in the container and we look for LXCFS stuff, we'll see that LXCFS is up and running, but it's using the global instance of LXCFS instead of a per instance LXCFS. So if we do that, now we do true, and go ahead and restart that container. So restart speed test in the default project. Now it's restarted. You can see there's a per instance LXCFS running. And if we go in there, the rest looks identical. So for within the container, you can't tell the difference. But on the host side, the extra process is running and provides like a nicely isolated LXCFS experience. And I believe that's it for this release. We go back to our list of new features. We've got the new cluster group configuration. That's then used for the CPU baseline and flags. Got the subpath custom volumes support, which is very useful for OCI. We've got the per storage pool project limits, the isolated oven, the per instance LXCFS, and lastly, what I showed as part of the subdirectory feature, the support for passing in environment files through launch. That's it for Incus 6.4. I said like a pretty well balanced release between new features, bug fixes, and features for kind of everyone. Hopefully a very good stable release and something you get to have fun with. As usual, you can go on our online demo to play with this today. It's also available in the package repository that I maintain for Debian and Ubuntu. Other distributions will pick it up as they go. And just a reminder that for production users, we usually recommend staying on the LTS release. The only reason right now to not use the LTS in a production environment would be if you need the OCI application container feature, because that will not make it to the LTS until 7.0 LTS. Or if you need the cluster group configuration, because that also will not make it until 7.0. Both of those features effectively need database changes, and we never push database changes into the LTS. So even though we backport a lot of stuff lately into the LTS to make it as nice to use for everyone, we don't do those kind of major features. So if you need those, then you do need to switch to the monthly releases. Otherwise, you're good to stay where you are. And that's it for Incus 6.4. If you've got any questions, feel free to leave them down below. Go on the community forum, ask questions there, and I'll see you in the next one. Bye.